Hello to everyone. It's a great honor to have a presentation on annual AAPG exhibition and conference. I hope our investigation will be interesting and informative for you. The presentation is dealt with application of technology of joint inversion of gravity and other geological and geophysical data for exploration of technology induced and unswept gas accumulation. There are three main types of artificial reservoirs, which is mainly used for storage of natural gas. These are those created in massive salt beds within aquifers and in depleted fields, as well as in voids of mined rock caverns. Artificial reservoirs can be used also for storaging of wastewater, CO2, oil, and other different types of fuel. In any case, it's important to understand the spatial location and distribution of storage substance with artificial reservoir. Gravity can help in exploration of artificial reservoirs. Gravity is the method which is sensitive to mass changing. Storage substance with the reservoirs creates a gravity effect relative to a reservoir background. This effect can be measured on the Earth's surface. It should be mentioned that anomalous mass must be enough and create a gravity effect that can be measured by modern high precise gravimeters. On this slide you can see the anomalous mass dependent on depth, which created 6.4 microgal gravity effect, which is equal to average standard error obtained by our company in last year gravity surveys with the using of modern high precision gravimeters. Unintended artificial hydrocarbon accumulation are the result of non-optimal production regimes for accumulation under developed of underground gas storage. In case when mentioned technology-related gas accumulation contain minor gas reserves, an important question is to map their location in an economically effective way. We present the case of a gravity method application to find a technology-related gas accumulation within Olyshivka, UGS, Ukraine. Olyshivka UGS was created in a natural aquifer of Bathonian and Bayesian of Middle Jurassic in middle 16th for the aim to supply seasonal demand on gas in Kiev. Reservoir is water-bearing horizon with good quality and consists with brittle sandstone and fine sand with average porosity 35%. Structurally, it is an extended Brocchian anticline with up to 15 meters effective thickness on the depth near 700 meters below ground level. Olyshivka underground gas storage has 660 million cubic meter of total gas capacity and 310 million cubic meter of working gas capacity. Since 2011, UGS had been exploited only for withdrawing. Withdrawing is accompanied by a lot amount of sand recovery, which occurs storage wells failure because of filter congestion by sand. Gradual increasing of water influx in storage wells had been observed during gas withdrawal. This situation is probably caused by project exploration regime disturbance in previous years. 356 million cubic meter of gas contained in UGS at the moment of gravity acquisition as of spring 2016. Average storage pressure in storage well is near 52 atmosphere. Most storage wells need to be repaired because of sand corks and water inflow. As of 2016, only 2 of 32 storage wells were used for withdrawing. Gravity exploration was used for well water inflow reason determination because gravity exploration gives an opportunity to separate gas saturated and water saturated rocks. High precision gravity was executed in 2016. High precision gravity measurements were taken within all area of interest. It was near 120 kilometers by 100 to 100 meters gravity station network. Modern gravity centric CG5 were used as well as modern GNSS by Trimble. Strictly observance of field survey standards and effective quality control gives an opportunity to get measurements of gravity with standard deviation 5.6 microgal and height measurements with standard deviation 13 millimeters. Standard deviation of complete Bouguer gravity was 7.3 microgal. This accuracy is more than twice lower than the theoretically calculated gravity effect from the artificial reservoir of Olyshivka UGS, which is between 14 and 44 microgal. Calculated gravity effect is difference between gravity from 3D model with gas saturated UGS reservoir and 3D model with water saturated UGS reservoir. UGS reservoir parameters, gas volume, storage pressure, gas water control, etc., used for modeling is real at the period of gravity survey execution. The only gravity by itself is poor instrument for solving tasks related to exploration of technology-induced gas accumulations. This task can be solved only in complex and coordination with all qualified geological, geophysical, and industrial data. All available data should be integrated into one coordinated 3D geological model. Rock density is used as parameter for this model because rock density is directly related to gravity and in other hand is good indicator of rock lithology and fluid saturation of rock. Interpretation process includes construction of heterogeneous 3D density model based on the inverse problem solution for gravity data in combination with our geological information, considering geological meaningful restrictions on density variations. Inversion provides determination of optimal model parameters to fit best gravity data and all available geological and geophysical information. Observed gravity adjusted with complete Bouguer anomaly is used as controlling function in the inversion. The final stage of technology is analysis of the final inverted 3D density model in terms of assessment of spatial distribution of reservoir properties and defining of the location of the hydrocarbon saturated reservoir and its exploration priority. Initial 3D density model of Olyshivka UGS is coordinated with all available geological and geophysical data. The structural framework of 3D model consists of 24 surfaces and was built using two-dimensional seismic and well tops data. 3D density model consists of 65 million cells with planar dimension 100 and 100 meters, and vertical size 2.5 meters. Planar 3D model dimension are 17.5 and 9.2 kilometers. The depth interval of the 3D model is from 0 to 10 kilometers. Input data for model building was two-dimensional legacy seismic data, well data, petrophysics by core, gas pressure measured in wells at the period of gravity survey. Well logging was used for density and porosity estimation. Rock density is calculated mainly from spontaneous polarization log using the relation between porosity and density, and also from sonic log using modifying Gardner equation. You can see an example of calculated rock density in well of Olyshivka UGS. Initial 3D density model was verified by gravity and get 7.2 milligal of initial misfit. The next stage was joint inversion. 3D density model was refined by joint full depth 3D linear inversion of the surface gravity field and well data. The standard deviation between observed and calculated gravity fields for the final 3D density model was 44 microgal. Regarding the gravity field, the initial 3D density model was improved on 164 times. Two low-density zones related to artificial gas saturated reservoirs were mapped as a result of obtained 3D model analysis. On the slide, you can see a slice of UGS reservoir in 3D density model. The first low-density area is located on the northeast from storage wells. It should be mentioned that this zone matches with high porosity by core in wells within this zone. The second zone is located on the southwest and probably formed during UGS exploration. This area has a favorable structural condition for gas flow. 3D model of current gas saturation of Olyshivka UGS was calculated using the obtained 3D density model, core analysis, and known petrophysical dependencies. On the slide, you can see the slices of current gas saturation within UGS reservoir. Predicted contours of gas-saturated rocks contoured by 70% level of gas saturation. The northeastern area located within northeastern wing of UGS structure. Area is shifted to the east from apical part of structure where the most of storage wells are located. This area partially covered with gas presence contour established earlier. Predicted area has difficult non-anticline shape and divided into 4 subzones. With only one high saturated zone with more than 70% of gas saturation. This zone can be developed as artificial gas pool in further. The second southwestern area is located near anticline fault divides to uplift. This is complete zone of low density and located outside of zone of working wells of underground gas storage. It should be mentioned that predicted gas saturation is confirmed by well test in 2 wells within this zone. probably formation of artificial gas pool caused by UGS exploitation regime disturbance in previous year. Because of inability of using of this part of reservoir in gas storaging, it's proposed to be developed as separate industrial gas pools. For assessment of gas volume within two mapped pools, volumetric method was used. Results of Monte Carlo modeling were used as independent gas volume rating within these reservoirs. Real parameters of Olyshivka underground gas storage were used as input data for modeling. Taking into account the executed calculation, there is 82% of UGS balanced gas volume with 50% of probability is located within two new mapped artificial pools. Gas saturated thickness and porosity are deciding parameters for gas resources. Provided exploration ensured the mapping of artificial reservoirs within UGS and explaining of their formation reasons. High accuracy gravity survey and technology on 3D joint inversion gave an opportunity to build 3D model of current gas saturation and calculate gas volume within mapped gas pools. Today there are 661 worldwide facilities of natural gas storage. Also, wastewater, CO2, oil, and other different types of fuel are subject of underground storage. 3D joint inversion of gravity, seismic, well data, petrophysical, and geological information is the effective way to obtain meaningful information from gravimetric data for exploration of technology-induced and unswept gas deposits and other artificial accumulation. Thank you for attention. It will be pleasure for me to answer your questions.